For thousands of years, human engineering has followed a simple additive logic. We gather materials like stone or brick and stack them from the ground up to create a structure. In Western India, the Ellora complex presents a massive departure from this tradition, hiding one of the most complex excavations in history within a single basalt cliffside. From above, the Kailasa temple looks like any other traditional Dravidian complex, featuring the same symmetrical spires and gathering halls you would find in a building assembled from thousands of individual stones. But here, the builders used no mortar and no bricks. There are no joints because the entire multi-story complex is carved from a single continuous mass of basalt. Rather than building upward, the creators of Kailasa began at the very peak of the mountain and carved their way down, removing the earth to reveal the temple inside. This top-down method carries a terrifying risk. If the architects made a single structural miscalculation during the descent, the thousands of tons of stone left for the roof would have collapsed into the dig site, instantly ending the project. This diagram represents the scale of the initial task, removing over 200,000 tons of solid basalt just to isolate the topmost layer of the temple from the mountain. Because they worked from the top down, the architects had to coordinate every room and hallway in advance. They had to account for the spatial layout of the final temple before the first chisel even touched the rock surface. Subtractive carving is permanent. A single misplaced strike or a crack in a supporting wall cannot be repaired with mortar. One mistake could ruin the structural integrity of the entire building. Thousands of artisans spent decades driving iron tools into the bedrock, enduring constant dust and heat as they extracted the temple's form. As the work progressed from the roof down to the upper halls, the crew used the mountain's own slope to clear debris, while simultaneously ensuring that the stone left above remained stable and supported. The top-down method required constant evaluation of the site's geology, turning the construction into an exercise in high-stakes spatial mapping. Once the exterior shell was defined, the focus shifted to hollowing out the internal chambers, a task that required tunneling horizontally into the heart of the stone. To create these interior spaces, workers carved out rooms while leaving solid mass overhead for a freestanding ceiling. Builders carved columns directly from bedrock as they descended, ensuring the ceiling remained supported by the earth's mass. At the courtyard floor, the heavy work of stone removal met the sculpture's fine precision, revealing intricate depictions of Hindu deities like Shiva and Vishnu. At the lowest level, monumental elephants were carved, positioned to look as if they physically carry the weight of the entire temple on their backs. The base of Kailasa marks the final meeting of the project's two extremes, the broad engineering of mountain removal and the fine-grained control of the sculptor. Long after the builders left, the temple settled into a deep pool silence, with the shadows of the excavation pit providing a sanctuary from the midday sun. This multi-generational effort was fueled by a level of devotion that allowed builders to commit to a project they knew they would likely never see completed in their lifetimes. Today, the temple remains a living monument where visitors still walk through the same stone halls that were carved over 1,000 years ago. Because Kailasa is part of the Earth's crust rather than a structure built upon it, it lacks the joints and seams where traditional buildings typically begin to fail and decay. By working within the mountain rather than adding to it, the builders bypassed the structural limits that typically dictate how high or wide a stone building can go. Kailasa remains a wonder beyond time because it isn't just sitting on the earth, it is the earth, transformed.